All right. So we are going to be looking at your Go Math book, Lesson 710. And I'm just trying to get a good view on it for you. All right. So let's go ahead and get started. So first of all, it's kind of a weird deal that they have going on here. So interestingly, it does not like the way I have the camera angled, and it was working fine, and now it's not. Orientation is locked. Rotate device. Seriously? Wow. All right, well, that's weird. All right, let's try again. If at first you don't succeed, try again. All right, so when I look at it, it says, and I'm going to start with number 2. When you look at number 1, first of all, it's a lot of mental math. It does say to guess, like that's what that says. So basically you're trying to find two numbers that are going to multiply together to give you a given area. Once you find those two numbers that will multiply together to give you the given area, you need to decide if those numbers will follow this given rule. So it's kind of like a twofold question and quite a bit of steps. I really did have to look at this before I was able to post it for the person who requested it. So Anna, you are on. I'm just letting you know that this is not your homework. Somebody had requested the video, but certainly always good review. So the question says, number 2, Marisol is painting on a piece of canvas that has an area of 180 square inches. The length of the painting is 1 1/4 times the width. What are the dimensions of the given painting? So I'm going to circle my important numbers. It has an area of 180. And I know that the length is 1 1/4 times the width. And I need to figure out what are the dimensions. So it doesn't tell me the length and it doesn't tell me length, but I know that area is equal to length times width. Are you guys able to see that? Yeah, you can see it. Okay. And it does give me the area. It says that the area is 180. So essentially, I'm trying to find two numbers, a length and a width, that can multiply together to equal 180. That's going to be step 1. Then when I find those two numbers, I need to decide if it's going to be if the width could be 1 1/4 times the length. So first of all, you want to think about your factor pairs for 18. In other words, two numbers that will multiply together to equal 18. So I've got 1 and 18 would multiply to equal 18. 2 and 9. 3 and 6. 4, oh, nope, 4 doesn't work. 5, nope. 6. Okay, so basically we've listed our factor pairs. We've got 1 18, 2 9, and 3 6. Now when I looked at these, I realized that one of them would have to have a 0, because I have a 0 here. It's 180. So if I added a 0 to any of these, it would match this given rule 1 and 1/14. So I decided, you know what, I need to think larger scale. I know that, let's go here. I know that 10 times 12 is 120, but I need much larger than that. And let me think. I know that 12 times 12 is 144. I need larger than that. I know that 14 times 14 equals 196. Oh, that's too high. But what I do recognize now is that my two dimensions are going to be somewhere between 12 and 14. Again, because 12 times 12 is going to get you to that 144. 14 times 14 is get you 196. So now it becomes trial and error. I've kind of got an estimate of where I should be between. And now I'm going to try and see if it works. So I'm going to start with, let's see, this was too low. 12 times 13 is not going to give me enough. So let me try 12 times, let's say, and I'm going to go up and down so I can multiply 12 times 14. So 2 times 4 is going to give me an 8, and 4 times 1 is going to give me a 4. Drop down my 0. Many zoos and many animals. 1 times 2 and 1 times 1. Oh, 168. Close, but not there yet. Let me see if I can bump this up to 15. 12 times 15. So 5 times 2 is going to give me 10. Ooh, maybe that gives me a 0. Regroup my 1. 5 times 1 is 5, plus 1 more is 6. Again, many zoos. I got to drop down a 0, representing that now I'm working in my tens place. 1 times 2 is 2. 1 times 1 is 1. Add those two partial products. I have, oh, look, I have 180. So I was able to multiply these to equal 180, but that doesn't yet mean that that's the correct answer, because the other part is, there's a little caveat to it. I need to make sure that 12 and 15, the length of the painting is 1 1/4 times the width. So in order to check that and see if it's 1 1/4 times the width, I know the length is 1 1/4 times the width. So what I'm going to do is I'm going to take the lower number, and the reason I'm taking the lower number is because when I multiply a number by a fraction greater than 1, your other number would be bigger. So if I multiply 12 times 1 1/4, my answer is definitely going to be bigger, so it would have to be the 15 if it works. So let me try it. 12 times 1 1/4. Okay, so I know that when I multiply by a fraction, easiest way to do it would be to turn this into an improper fraction, which would be your whole number times your denominator and adding it into your numerator. So 1 times 4, I'm going to add 4/4 to my 1/4, and now I'm going to multiply 12 times 5/4. So 12 times 5 is 2 times 5 is 0, remove my 1. 12 times 5 is 60 over 4. And 64 is in fact equivalent to 15 whole. So we were able to multiply 12 times 15 to get 180. And then we checked, we used that smaller of the two dimensions and we multiplied it by the fraction that was greater than 1 to see, was the length 1 1/4 times the width, or I guess this would be the width. So we multiplied the smaller number by the fraction greater than 1, and we did end up getting 15. So those dimensions did work. 12 feet by 15 feet. Oh, by the way, do you like my nails? They're super cute. They got some sparkle to them. Yeah, it's called a nail tip. Anyways, that was total random, but I thought I'd share that with you because why not? All right, so let's move on. And just going to slide this down a little bit, and we're going to look at number 3. Okay, so number 3. A small plane is flying a banner in the shape of a rectangle. The area of the banner is 144 square feet. The width of the banner is 1/4 the length of the banner. What is the dimensions of the banner? So again, I always try to go through cubes before I start anything. I know that the area, so I'm circling my numbers, the area is 144 square feet. The width of the banner is 1 1/4. Okay, so that's going to be my width is 1/4 the length of, which of is telling me to multiply, okay. What are the dimensions? So again, it doesn't tell me the width. It says that the width is 1/4 of. So I would have to multiply those. It does give me the area just like it did before. So I'm looking for two numbers that are going to multiply together to equal 144. And we talked about above that we knew that 12 times 12 equaled 144. However, this would not follow the rule of 1/4. If I were to take 12 and multiply it by 1/4, I would not get this. So although we have somewhere to adjust from, we don't have exactly what we need. So I want to look for two numbers that I could do instead. I could divide this by 2, so cut it into a half and then multiply the other one by 2. So for instance, half of 12 would be 6 and double of 12 would be 24. So I just reverse my factors. There's a little bit of trick in there. And 12 times 24 in theory should equal 144, but let's check. 6 times 4 is 4. And 24, we're going to regroup my 2. And then 6 times 2 is 12. Plus 2 more would give me 144. So those two also multiply together to equal 144. Again, that does not mean it works, because I could also divide by 3, multiply by 3. We're just going to see if it works, because it needs to follow this rule. The width of the banner needs to be 1/4 of the banner. So I know I'm multiplying by a number less than 1, which means my answer would be the smaller number, meaning I want it to equal this. So if I multiplied 24 by 1/4, will it equal this? So again, I'm going to multiply 24 by a fraction less than 1, so my answer is going to be smaller, because I'm taking 24 and cutting it into 4 pieces, and I only get to keep one of them. So whole number times your numerator, because this is the same thing as saying 24 over 1. 24 times 1 is 24. Your denominator stays the same. Think about this as division. 24 fourths, or 24 divided by 4, which does equal 6 whole. Check, it works. So your dimensions here are going to be this one that we came up with, 24. This is inches, 24 feet. Oh, 24 feet. Oh, your other one above was inches. Strike that out. Inches, sorry. Inches, wrong unit of measurement, lazy me. 24 feet by 6 feet. And then there you go. So let's look at the last one that you have on this side of the sheet anyways. Trying to get this to prop where it will stay. It's not a good location for it. I don't know. All right, well, I'm just going to try to kind of hold it, because it doesn't really want to completely cooperate. So an artificial lake is in the shape of a rectangle and has an area of 9/20 square miles. So again, when it's talking about a rectangle, it's really essentially talking about an area model. And the area is going to equal 9/20. The width of the lake is 1/5 times the length. What are the dimensions of the lake? So again, I know that I need to find a length and a width that will multiply together to equal 9/20. The width of the lake is 1/5 times, and so this will be something that I'll do as a second step. And then what are the dimensions of the lake? This is a pretty awesome lesson. I did not do this with my students, but it would definitely be very challenging for those students who need that height order skills added on, which I like. All right, so first of all, I know that I'm looking for two numbers that are going to multiply together to equal 9/20. So essentially, you're looking for two numbers that will multiply together to be a denominator that can equal 20, and two numbers that can multiply together as numerators to equal 9. And when I do that, first of all, I know that the only factors for 9 are 1 and 9 and 3 and 3. I can try either. I'm going to venture to guess that it's not going to be 1 and 9 in order to get that 1/5. I'm going to try the 3 and 3, and then I'll just see if it works. Here you have several numbers you could try. We've got 2 times 10 equals 20. We've got 5 times 4 equals 20. So here there is a little bit of a variation to see which one would work. If I do, let's just try 5 times 4. If I do 5 times 4, both of these equal. This equals 9/20, it's no problem. But what I need to check is when I multiply 1/5, would these work? And so before even multiplying 1/5, I can tell you right off the bat it's not going to work, because both of these are fractions less than 1. And so I'm going to end up getting an answer smaller than these. But in the interest of you understanding it, we're going to go ahead and do it. So if I did 3/5 times 1/5, I would get 3/10, and I don't want it to be 3/10, I want it to be 1/5. So that way it would not work. And if I were to do 3/4 times the 1/5, I would get 3/20, which is also not going to work because that's not my second dimension, so it's not going to work. It's not my length and my width. So let's see. I've got 3 and 3. I think I'm going to stick with that. Let's try the 2 and 10 and see if 2 and 10 will work. So 2 times 10 is 20, and so now I'm going to see if I multiply one of these, will it end up equaling 9/20 or 3/10? So again, I'm multiplying by a fraction less than 1, which means my number is going to be getting smaller. And if I multiply, I need to multiply the bigger number and make it get smaller. So I'm going to multiply 3/2 times 3/2 times the 1/5 and see if it works. So when I multiply 3/2 times 1/5, I've got 3 times 3 is 3. 2 times 5 is 10. So if this is my first dimension, this does work because it ends up being my second dimension. So your dimensions are 3/10 times 3/2. Now you could also put, you could also put that 3.5 is equivalent, 3/2 is equivalent to 1.5. So it could also be 3/10 by 1 1/2. Either way work, and again, add your unit of measurement as miles. So that's what I got for you on this side of your sheet. Have a great night. Enjoy your 3-day weekend.